You may have seen before that problems involving work are similar to questions about distance or uniform motion. In that case, we have rate times time equals distance. Here, we have rate times time equals work, or R times T equaling W. And we have two people working on this job, Donita and Harold. We have that it takes Donita 2 hours less than Harold. So let's call Harold's time working on the job X. And since Donita's time is being compared to Harold's, 2 hours less, so 2 subtracted from that, X minus 2 is Donita's time. Now, we can also use that to talk about their rates. We could divide both sides by t. So if R times t equals W, then dividing both sides by t, R is equal to W over t. But in that case, we know what we're going to be putting in for t. What are we putting in for W? Well, think of 100% of the delivery job being done. 100%, or one whole job. So if we have, for the rate, Harold would have 1 over x, and Donita would have 1 over x minus 2. We're not going to multiply those by the x minus 2 and the x. That would be if they were working individually, and then they would get one whole job done. We're trying to find out what these rates are if they work together. Now, up here, I had the time it takes them to work together expressed as 1 hour and 20 minutes. You may notice that down here, I rephrased that as 80 minutes. And yet, so we've had this mixture of hours and minutes. Here we have the minutes purely, but the times that we're talking about, the comparison of Donita's time to Harold's time is purely in hours. So we're going to have to take that 80 minutes and express it as hours. So 80 minutes over 60 minutes in an hour. Reduce that 1 hour and 20 minutes, or 80 minutes, if we divide top and bottom by 20, they are taking 4/3 of an hour when they work together. Since we're trying to find out about their working together, putting in 4/3 there. And I'm going to check something here real quick before going too much further. What we should actually be looking for is not what their rates are, but the time each takes when working alone. Alright, so multiplying these, rate times time equals work. I'm not going to do anything with simplifying at the moment. Just leave it as this for the time being. Working for that 1 hour and 20 minutes or 80 minutes, i.e. that 4/3 of an hour, this is how much each of them would get done on the job when they're working together. And we want that total amount of work to equal the one whole job. So those two things added together equaling 1. Now I will simplify this part, 4 times 1 being 4. Similarly, with the amount of work that Harold gets done, opposed to total to 1. We can't do anything to factor these further, so our least common denominator, if we think of the 1 over here as also over 1, that doesn't contribute anything to the least common denominator. 3 is a common factor. X is a common factor. Well, sorry, no it's not. It is showing up just once to the first power. And so that goes in the least common denominator. And the x minus 2 shows up just once. The 3, although we saw it twice comparing the exponents, the highest exponent is 1. And so we still just have that factor of 3 to the first in the least common denominator. So I'm going to multiply everything on both sides by that LCD. And on the left side, we need to make sure that we distribute before we cancel. Multiplying that least common denominator to the 1 that's on the right side will just give us that least common denominator. So distributing 3x times x minus 2 to the first fraction, and to the second, I'll worry about simplifying the right hand side shortly. We're going to have the 3 and the x minus 2 canceling on that first group. So we have 4 times x. We'll have the 3 and the x canceling on the second. So 4 times the quantity x minus 2. Now I'm going to do a little more distributing the 4 on the left hand side, distributing the x on the right hand, sorry, the 3x on the right hand side. And now we can see that we are dealing with a quadratic equation. So I'm going to get everything on one side equal to 0. Before I do that, combine the like terms that were on the left. Now I'm going to subtract 8x and add 8. Minus 6x minus 8x will give you minus 14x. And then plus 8. Now we've got that equal to 0. Now let's see here. This can be factored. Some of you may have learned the AC method. A is 1 and C is 8. They're both positive. So AC is 24. They have to add up to a negative 14. And the way to get that and have them also multiply to positive 24 is that they're both negative. Negative 2 and negative 12 will do the job. If I use those two numbers to split up the negative 14, then we could use factoring by grouping. Factor out an x from the first group. Because the second group has a negative lead coefficient, I'm going to factor out a negative 4. And that also gives me 3x minus 2. So 3x minus 2 is in common. The other factor is x minus 4. Set each of those factors equal to 0. On the first one, 3x equals 2 will tell us that x equals 2/3. That would be in hours. And the latter, another possibility, is that Harold takes 4 hours working alone. But if x equals 2/3 is a possibility for Harold, two-thirds of an hour, and we subtract 2 so that we can figure out Donita's time, two-thirds minus 2 is going to give us a negative number of negative 4/3 hours for Donita. And that does not make sense. So we're going to be rejecting this. Keeping the x equals 4 hours. Then we would have that Donita's time is 2 hours less. So Donita, working alone, takes 2 hours. I'm going to do a check on this. That means that Donita takes, she has a rate of 1/2. She does one job in 2 hours. And if we multiply her rate by the time working together of 80 minutes, we should have that as 4/3 of an hour. 4/6, or 2/3. She gets 2/3 of the job done in those 80 minutes. Harold, his rate would be 1/4. So multiplying his rate of 1/4 by the 4/3 of an hour, cancel the 4's, we get 1/3 of the job done in those 80 minutes, or 4/3 of an hour. Donita's getting 2/3 of the job done. Harold's getting 1/3 of the job done. Adding 2/3 plus 1/3, they get working together the whole job done in those 80 minutes, or 4/3 of an hour.